Welcome to qnawire.
So for this problem, we're going to be using Stokes Theorem, and more specifically, we're going to be using it with regards to a paraboloid with the equation modeled by z equals 1 minus x squared minus y squared in the first octant. So before we begin, we want to remind ourselves what Stokes Theorem says, which is this right here, that it's equal to the single integral of f dot dr, or we could view it this way as well. And we know how to calculate the curl of f. So what we're going to do for this problem is we're going to find the curl of f. Since f is a vector pqr, the curl of f will be the partial derivative of r with respect to y. So let's start by looking at what f looks like. So keep in mind, this is p, this is q, this is r. So r with respect to y, the partial derivative, will be 0. And then we subtract that by the partial derivative of q with respect to z. So that'll be y. Then we have the partial derivative of p with respect to z, which is 0, minus r derivative with respect to x, which will be z. And then, as you can expect, we'll get this right here for the third component of the vector. So that means that the curl of f is equal to negative y, negative z, negative x. And with that in mind, we can now use part of our integral that we have. So what we want to see is negative p if we view it in terms of the double integral of the negative p times derivative of g with the partial derivative of g with respect to x minus the partial derivative of g with respect to y plus r dA. What we'll end up getting as a result will be a negative y, and this is going to be the curl of f dot ds. So given that we know ds will do this, and this will be a negative 2x. And then this is because we know that g, or the z function, is 1 minus x squared minus y squared. So this is where the negative 2x is coming from. And then this right here will be a negative z from the curl of f times a negative 2y plus a negative x. And we'll combine this together, and we'll end up getting negative 2xy minus 2yz minus x dA. We'll substitute z as being 1 minus x squared minus y squared. So we'll put that in right here. And then we can multiply all this out. Then we'll want to use cylindrical coordinates. That'll make things easier. So how we're going to write this is the integral from 0 to pi over 2, because we know this is just in the first octant. and then the integral from 0 to 1. This is going to be of negative 2r cosine theta times r sine theta, because it's negative 2xy. And we would continue with this, but this can be simplified even further. So we'll do it in the simplified form, which is negative r cubed sine 2 theta minus 2r squared sine theta plus 2r to the fourth sine theta minus r squared cosine theta dr d theta. Once we simplify this further, we have the first integral, the d theta first integral will end up giving us the negative sine of 2 theta over 4 minus 2 sine theta over 3 plus 2 sine theta over 5 minus cosine theta over 3. This is the final integral that we have to evaluate right here. And what we end up getting when we do this is negative 17 over 20, which we see is also a negative 0.85. So while it takes some time, if we're able to use Stokes theorem, it actually makes the process much easier because we're allowed to use the curl of f in order to evaluate the integrals.